In this video, I'll be presenting my refactorization of a graph embedding method called the TransE. This method is an implementation of the paper Translating Embeddings for Modeling Multi-Relational Data. It addressed the problem of embedding knowledge or relation into a same vector space representation. The idea is that for a knowledge triple, head, relation, and tail, that for the embedded vector of head plus the embedded vector of relation is close to the embedded vector of tail. To do that, the algorithm uses gradient descent to minimize the loss function over here. The input of this method is a list of triples of head relation tail, and also a entity to ID text and a relation to ID text that maps each entity or relation name to a unique ID. The output is an embedded vector of all entity and relation terms. Right here, you can see an example of the input. This is the entity, this is the tail, and this is the relation. Here is an example of the output. This is the entity name, and here, the numbers over here is the embedded vector. Now let's look at a demo. Here's a Jupyter notebook for my TransE refactorization. First, we need to import the necessary libraries. They are TensorFlow and my factorized TransE class. Then we will set up input and output folder. In this example, we will run one of our benchmark data, WordNet 18, and initialize the TransE model. Then we read the data in the input folder by calling readDataset function. You can see that there are about 40,000 unique entities and 18 relations. Here I give a visualization of the data, so that this is the head entity ID, this is the tail entity ID, and this is the relation ID. Next then, we will do embedding on the input data. Here I set the embedding dimensions to 300, and the stop factor at 1.0, and a batch size for gradient descent is 4,800, and the maximum iteration is 3. For demo purpose, I set the iteration size to 3, but the ideal to run the WordNet dataset is about 1,000. Here I show you the example of the embedding output. This is an entity ID right here, and then this is the embedding of that ID. And right here, I'll show you an output of the relation embedding. This is the relation entity, and then right here is the relation embedding. Last, I'll show you the evaluation result. To evaluate on the embedding, you can just call the evaluate function in the model, and it will return to you the mean rank and heat. Over here, the mean rank is high and the heat is low. It's because the iteration size that we choose is low. For better performance, you will want to tune the variables such as embedding dimension and maximum iterations to boost up the performance.